In this video, we will look at some of the problems based on spring forces. Figure below shows identical springs. Identical springs means they have the same spring constant. Two blocks of mass m each is hanging from the spring system as shown in the figure. If in system 1 the stretch is 0.2 meter when you hang the mass, how much will system 2 stretch? So first of all, because they are identical, so let's write the value of spring constant as k in each of the diagram. So for system 1, because it's in series, so for system 1 in series, we know that 1 over k total is equal to 1 over k1 plus 1 over k2. In this case, both of them are same, so 1 over k plus 1 over k. That's going to give us 2 over k, and we need to flip it to get the total spring constant or equivalent spring constant, which is k over 2. For system 2, we are going to do for parallel, it's in parallel. So k total will be equal to k1 plus k2. We can see that these two springs are in parallel. So that's k plus k, that's going to give us 2k. Now we know that Hooke's law states F equal negative kx. We are just going to ignore the negative and just write it as kx because we are interested right now only in the magnitude. So F is equal to kx. We can see that F, that is a force, is the weight of the mass, and because both the masses are same, so we have the same force for both the systems. And this equation clearly shows us that k is inversely proportional to x. So we can write k1 over k2 is equal to, now because it's inverse proportion, so be careful, k1 is up, so x1 will come down, k2 is down, so x2 will come up. So we want to find out if system 1 stretches by 0.2. So that means we know what is x1. x1 is 0.2. How much will system 2 stretch? We don't know what is x2. k1, we know what's the value for k1. It's k over 2. Not the value, but we know it in terms of k. So it's k over 2 here. And for system 2, it is 2k. So let's just substitute that. K over 2 over 2k, and we can simplify this because the k's will get cancelled out, and I'll get 1 over 4 equal x2 over 0.2. So if we calculate this x2, we'll get that as 0.2 over 4, which is going to give us 0.05 meter. So that's the value for x2. Now next question, again on spring forces. How much would the extension be if a mass of 4m is hung from a series arrangement, just a series arrangement of two identical springs, given that each spring stretches by x when a mass m is hung from it? Okay, so if you have a single spring, that's what it says, each spring stretches by x when you hang a mass m to it. So this is our single spring. Now if we want a series arrangement of two identical springs of the same kind, so same identical springs, let's put them in series, and now the mass which is hanging from them is 4m. So this is k, but the mass is 4m. So again, let's call this as system 1, and let's call this as system 2. So for system 1, we know what's a spring constant. For system 2, it will be 1 over k total equal 1 over k plus 1 over k because it's in series, which is 2 over k. So we'll get the k total for this system, which is in series, will be k over 2. Now we'll write, again, let's write down F equal kx. That's the Hooke's law. Again, I'm not taking negative, just we want to compare. We can see that this time the force as well as the extension and the k, so all of them are changing. Nothing is constant here. So we are going to write it as F1 k1 x1, and for the second system we'll write F2 k2 x2. let's just divide these two equations, F1 over F2 equal K1 x1 over K2 x2. Now F1, the force is the force of gravity. So for 1 it is m, so we can write that as mg, and for 2 it is 4m, so we can write that as 4mg, which is equal to, now K1 is K because it's just one spring, and K2 is K over 2. So we'll write that for the second system it's K over 2. And x1, we said that the first system, it says that one spring, each spring stretches by x. So I can remove this x1 and then write it just as x, because that's what they are using in the problem. And we want to find out how much will the second system 2, when you have it in series arrangement, how much would it stretch. So m and g can be cancelled out from both the sides, k can be cancelled out, so we get this as 1 over 4 equal x over 0.5. so this is, there is a half here which I am going to write as 0.5 x2, and so I will cross multiply. 0.5 x2 is equal to 4x. So what I did here is I'm just doing cross multiplication because I want to know what is x2 in terms of x. So x2 will be 4x over 0.5, and 4 over 0.5 will give us the number 8. So that means in the series arrangement we'll have 8 times the extension as compared to that of one single spring.